Katie. You have Maddie Crum to thank for every time you get a video because we always forget. We don't forget you, we just forget to turn on the recorder. So we've just been doing a warm-up here of this problem. But, okay, so anyway, everybody good on here, right? Everybody got to here. Okay, yes, Paul. Okay, so this term, because it's x and y, has to be product rule, right? So the first function is like x to the fourth. The second is y squared. But right, this right here? Okay, so derivative of the first is 4x to the third, right? Yeah. Times the second. Oh, after you do this? Yeah. Okay, so now I have to solve for dy dx. Okay? So I need to get all the terms that have dy dx over to one side. So that's where I took this term, and even though I wrote it like this, that is really the same thing as 2x to the fourth y dy dx, right? So I took it over, I subtracted it over to the other side to get all my dy dx terms together. So in kind of between here and here, what I did is I subtracted this over, and then when I rewrote it, I just went ahead, because all I have over here are the dy dx terms, so I went ahead and took them out, took the dy dx out. So that's 21 halves y to the 1/2 minus 2x to the fourth y. Does that make sense? Yeah. Okay. Jillian. The 9 halves was right here. The 9 halves, yeah, no decimals, right? Okay. Okay, so now though in here, since we don't we need this is a fraction, right? And this is a fraction. So you could build your common denominator like you always would, right? Like put a 2 down here and multiply this by 2, etc. But I just wanted to show that when your denominator is just a number, like it's not a variable, and it occurs on both sides, one of the easier ways to wipe out just a fraction with numbers in the denominator is just multiply the whole thing by that number, right? So we can just multiply everything by 2 here. And that just gets rid of that pesky fraction easily, right? So now this becomes 8x to the third y squared. This gets rid of those 2's. So 9x to the 1/2 equals dy dx 21 y to the 1/2 minus 4x to the fourth y. Again, you wouldn't have to do it like that. You could go ahead and rewrite both sides to be over 2, but that's just easier when you're just dealing with a number. Okay? Does that make sense? I did. I multiplied everything. 2, 2, 2, 2. No, I mean, I could have done it up here when they were all still dy dx, but I don't have to do that once I've taken it out. So now, when we solve for dy dx, all we have to do is what? Divide, right? So we're going to divide. Actually, I'm just going to go ahead. Oh, shoot, I think I am. So our final answer is again, dy dx equals 8x to the third y squared plus 9x to the 1/2 over 21 y to the 1/2 minus 4x to the fourth y. Bless you. Okay, does that make sense? Did you all do better on that, on this first term stuff here then? Does that make a little more sense? Okay. Okay. All right, go ahead and do the next one. So here's the answer. I left off Katie there for a second. So again, this is getting the common denominator over here, the y to the 1/2. And the purple is just showing, instead of always having to write it underneath where you're dividing, the other way to think about it is you're really just multiplying by the reciprocal. And we get that. So how many got that answer? Yeah. Ollie, how'd you do? Oh, sorry. The questions about that, Maddie? Okay, the 7, so when I needed to write this, so this is actually over 1 right now, right? So when I need to write it with a common denominator, the common denominator is going to be y to the 1/2. And when I take y to the 1/2 times y to the 3rd, again, you just have to add exponents, and 3 is actually 6/2. So I really am writing 1/2 plus 6/2 is 7/2. Okay, makes sense? It does get easier from here, but still have to know this. But. Okay. All right, gonna move on. Okay, yep. Okay, now implicit differentiation, even though it's different, right, and it's weird, it's still taking derivatives. And what's one of the things the derivative tells us? Slope of the tangent line, right. So the only real application we're going to do with implicit differentiation is just finding the equation of tangent lines, okay? And this is actually easier, because what's going to happen is we're going to take the derivative, but instead of having to simplify it so much and get common denominators, we get to plug in values for x and y, okay? So it takes a lot of the tedious stuff out of what we just did. So to find the equation of a tangent line, again, the derivative tells us what part of it. I think Grace already says it, tells us the slope, right? So what we're going to do on these couple of applications here is we're going to take the derivative for dy dx. We're going to substitute values of, we're going to be given x and y, because we're going to be trying to find a tangent line at a given point of a function. Because even though these functions are strange, like with x and y, and all that kind of stuff intermixed, they are still functions of just different shapes. Like we're going to do one that is a circle, you know, but they can have all kinds of weird shapes, and we're just trying to find tangent lines at a given point. So we take the derivative, we substitute the given values in, and then we solve for slope, and then we just plug it in. And we're even going to use a simpler version of a line, in that we're just going to use point slope. Okay, so remember point slope, if you're given a point, you use the variable y and then minus the y value of your point equals your slope times x minus the x value of your point. Okay, so that part is pretty simple. Okay, so let's try a couple of these. So can anyone tell me what that is an equation of? A circle, right? What about it? It's a circle that's better than A block. A block had no idea. We're not gonna graph circles, but this is just common enough. Like as an assumption teacher of the seniors, I want you all to know what this is. What's the circle? What do we know about the circle? It's what? What's the radius? Well, this is r squared. 10. So radius is 10. Right. Well, no. So Anna was right. So this is x squared plus r squared. X squared plus y squared equals r squared. Shh, girls, be quiet. So radius is 10. Where's the center of the circle? No. No, this is just a point. Ignore that for now. Just based on this equation, what's the center? At 0. Yeah, 0, 0. Right, because if it was somewhere else, it would be like x minus 1 squared. Does that ring? Okay, all right. Awesome. Just a little. So if we were to just sketch this, which we're not going, that's not part of this unit, but it would be at the origin, and the radius would be 10 everywhere. Okay? All right, so what we're going to do, good job, girls. So what we're going to do is we're going to try to find, so we want to find the slope of the tangent line that goes through this point that's on that circle, okay? That is tangent line to that circle. All right, so we're going to, so to make an equation, we need a point, right? If we're going to make this type of equation, we need an x and a y value, which we have, right? And we need a slope, which we can get by taking the derivative, right? So, yes, dy dx is, yes, that's our derivative, and that's going to be our slope. So, x squared, take the derivative, becomes 2x. Y squared, take the derivative, becomes dy dx. And 100 turns into 0. Okay, so now we solve for dy dx. So we can subtract 2x. We get 2y dy dx equals negative 2x. Divide by 2, y. So dy dx, which represents slope, is negative xy. So our equation for slope is negative x over y. So we can plug in 3 and negative 7, right? So don't forget here, again, this is negative x. So we're going to pull, so it's going to be negative 3 and then over 7, which is negative 7. So our slope becomes positive 3 over 7. Make sense? And then, so what's our equation going to be? So go ahead, try it. Y minus, you can tell me, right, y, y plus, so y minus negative 7, y plus, sorry, I may have led you on confusion there. Well, what comes before the x minus 3? 3 over 7. That's okay. Okay, so again, we plug in our x value, well, our y value into y minus, it was negative 7, so y plus 7 equals 3 7, x minus 3. Yep, we're done. Yeah. Well, they get a little bit harder, not a whole lot though. No, this really doesn't get a whole lot. I know, hey, come on, just so just stick with me, we'll be fine. Okay, I mean, calculus can only be so easy, you know, like it's calculus. So. Okay, all right, let's try another one. All right, so again, x squared, so this is not a circle. I'm not sure what the graph of this one would be. But what do we need to use here? Not carrying product, all right? Okay, so who wants to tell me what the derivative would be? Maddie, go ahead. Dy dx. Beautiful. Equals 0. Perfect. Okay. So now we get to dy dx by itself. What do we want to do? Subtract 2xy squared. So let's go ahead and rewrite. So 2x squared y dy dx. I'll just kind of rearrange those. Equals negative 2xy squared. Does that make sense?
For a second, I thought you rewrote the negative 2x, and I thought you switched x for it. I was like,
Oh, I hope I didn't. Yeah. And now we divide, right? Now, what does that simplify to? How does that simplify? No. Negative y over x. Did I get that? So your 2's cancel to give you the negative 1. 1x over 2 x's gives you 1x on the bottom. 2 y's over 1 y gives you 1 y on the top. So we get negative y over x. Everybody good with that? Okay. So who wants to tell me the equation? Okay, Maddie. Oh, actually, what is our slope then first? 2, let's see, negative 2 over negative 3, so it is positive 2/3. Okay, now, Maddie, you want to tell me the equation? Y minus 2 equals, beautiful. If I get with that, yeah, these are, and even when they get ugly, they're easier. What's that? Yeah. All right. You know, spring semester, senior year, this class is always a little bit of a struggle, but the best thing Assumption has ever done is to let seniors not take the exam if you keep an A. Because other than that, I would lose almost everybody, I think. This keeps you all paying attention. Oh my God, I thought you could say it was me or something. That well, there was a TikTok. Did you all see? There was a TikTok. There was of a student going up to her math teacher and saying, "Name 5 things." Yeah. So Maggie Issing, Miss Issing, sent it to me and Miss Fackler, you know, just to show us. And then that very next day, one of my Algebra 2 students goes, "This is Kurt. So name 5 things you use every day," and starts doing this. And I said, "Well, my keys, Algebra 2, and you know, something else." And she's like, "Oh my God, how did you know that?" Like Meg, like Miss Issing, keep me posted on anything math related on TikTok. Kind of blew her away. But yeah, just stick with this. I mean, A's are definitely still possible, even if you forget the common denominator stuff, but you have to know most of it. Okay, so now this one, oh, one more on the old way. All right, so again, we've got an X and a Y. This one's going to be a little more complicated, but the good thing about this is you can kind of choose to plug in X and Y at really any spot. Okay, so you don't have to go through all of the simplifying. So that'll become clear here in just a second. So let's just rewrite this first. Okay. Now take the derivative. So we get 6y dy dx plus 1/2 x to the negative 1/2 equals 0. Now we can go ahead and let's subtract the 1/2. So we get 6y dy dx equals negative 1/2 x to the 1/2 on the bottom. Everybody agree with that? Now, because we got that x on the 1/2, and that could get ugly. Right now, we could go ahead and substitute in our x and y's. Okay, so we can go ahead and say let x equal 4 and y equal 2. So we get 6 times 2 dy dx equals negative 1 over 2, 4 to the 1/2. Does that make sense? Yeah, that's going to end up being 2. So then on the left side, we get what? 12 dy dx equals negative 1 over what? 4. See, so here we avoided the whole come down there thing. God bless you. Well, why can we plug in right now? Well, because again, we're just, the whole goal here is just to find the slope at a given point. So since we have x and y values, we don't have to get it in its simplest form in order to plug those in. We can plug them in really whenever you get kind of leery about continuing, you know? Okay, so now we still have to, we're not completely done yet though. How do we solve for dy dx then? Well, we want to get rid of this 12. So, right, we still need to get dy dx by itself. Multiply by the reciprocal. Now it's coming up with the fractions. So we do 1 over 12, right? So dy dx, I swear it all comes down to fractions. I don't care how hard the math gets, it's the fractions that mess with everybody. So dy dx equals what, Palmer? Beautiful. So that is our slope. What's that? So then you're the negative 1 over 6y to x to the 1 half. Yeah. Because right here, when you try to get dy dx by itself, you would multiply by 1 over 6y. Is that what you did? Did you keep going? Did you not get that? Yeah. Okay, so now who wants to tell me the equation? Jillian? Okay, so it's not too bad. It's a little bit more complicated. It's still not as hard as it looks. Okay, can I go on? Everybody else listen? Okay. All right. Again, ugly equation. So a little bit different. So we're only given x, right? But we're still going to need y, right? So if you're given x, if you're given, oh, actually, I did want to do that. Yeah, if you're given x, how do you get y, Mary Grace? Plug it into which? This or the derivative? Right, this. Okay. So we are going to take a derivative, but before we do that, let's go ahead and find our y. Okay. So in all of these, and even the ones on 27, 29 are like this for homework, they all end up simplifying pretty easy. Okay, when you plug it in. So, but you do have to plug it in correctly. So we've got y to the third to keep, right? Plus 2 times 2 squared y. So again, I'm just plugging in. I'm not taking the derivative or anything. Minus 8y equals 2 to the third plus 19. So this is just to find y. So we get y to the third plus what? Plus 8y minus 8y equals, so, everybody good? It's 3. Everybody see it? So the 8y's cancel out. So we get y to the third equals 27. And then cube root of 27 is, well, that gives us our point. That gives us, not that big. That just gives us our x and y value. Okay, now we still have to turn that into a slope by taking the derivative, right? So now we need to find dy dx. So yeah, these problems aren't short. So 3y squared dy dx plus, somebody tell me what right here. What's that? 4xy plus dy dx 2x squared. Very good. and then minus 8 dy dx equals 3x squared. Now again, we can plug in at any time. I would rather, let's go ahead and collect the dy dx's on one side and move the other ones over, and then we can go ahead and plug in xy. You guys good with that? So we're going to just subtract the negative 4xy. And I'm going to go ahead and just take the dy dx out. So I've got 3y squared plus 2x squared minus 8 equals 3x squared minus 4. And now you guys go ahead and plug it in, see what you come up with. So right now we can plug in x equals 2 and y equals 3. Okay, so we get a slope of negative 4/9, and then we, recapping for Katie, and then we plug it in and get that equation. Okay, everybody good? All right, you guys, we have one more, right? Oh, shoot, okay. Y'all want one more? I thought I had 2 examples like that. Okay. So disappointing, I know. But you all feel okay about this? Okay, so this is better than the other one, right? Okay. All right, well then, well, we're done a little bit early, but it's okay. So you guys, so 17, 19, and 21, you're given the point, and you have to come up with the equation. 27 and 29 are like this last one, where you have to come up with the y value first, and then find the slope, and then find the equation. All right, and we'll just be done.